15, Probability, Session 2. Let's start. Let's start with the exercise 15.1. Question 1. Complete the following statements. Probability of an event plus probability of not an event is equals to what? So is equals to 1. That we already seen in the previous lecture. The probability of an event cannot happen. Cannot happen means the sun rises from the north. It is impossible event, so it is 0. So not happened is 0. Event cannot happen is 0. Such event is called the impossible event. Such event is called the impossible event. The probability of an event that certain happen. The sun rises from the east. It is certain to happen. So it is 1. It is 1. Such event is called the sure event or a certain event. So those things we already discussed in the previous class, right? The sum of the probabilities of all the elementary event of an experiment is 1, right? Sum of all the elementary event, we see that 4 upon 5 plus 1 upon 5 is equals to 1, right? In that manner, 1 upon 6 plus 1 upon 6 plus 1 upon 6 plus 1 upon 6 is equals to 1. So those examples we see in the previous lecture. So sum of all the elementary event of an experiment is 1. Probability of an event is greater than or equal to. Probability of an event is greater than or equal to 0 but less than or equals to 1. 0 and 1. That is the range. That is the range. Now question number 2. Which of the following experiment have equally likely outcomes? Equally likely outcome means what? Right? If I toss the coin, it might have a head or it might have a tail. Right? So probability of getting a tail is 1 by 2. Probability of getting a head is 1 by 2. So that means of all the outcomes, if all the outcomes are same, means probability of getting each and every outcome is same, then we can say it is a equally likely, right? Otherwise it is not equally likely. Now driver attempts to start a car. A car starts or does not start. Start, right? See, we have two possibilities, whether it is a start and whether it is not start, right? For starting, it has a 1 upon 2 probability, but not start, so there is a lots of reason that car doesn't start. There are lots of reason that car does not start, right? Whether there is a lot of fuel, whether there is some problem in the indicator, right? The engine might have damaged. So many probabilities will be there. So it starts, but if it doesn't start, we have lots of problems. So those are not equally likely events. Player attempts to shoot a basketball. He or she shoots or miss it. Right? Whether it is a shoot. If it is a shoot, it is fine. But if it is not shoot, so there are lots of reason. Right? Opponent might be stronger, so he come in front of the basket. Right? So and he might miss by throwing or by missing the velocity, by missing the judgments. There are lots of reasons. If it is shoot, it is fine. It's 1. But if it is not shoot, there are so many reasons. So that is why we can say it is not equally likely to occur. A trial is made to answer. True or false question. Answer is right or wrong. Right? It is but obvious whether it is a right or whether it is a wrong. Sun rises from the east. True or false? So we can say it is true. We can say if it is rises from the west, what we can say it is a false. Do we have another answer rather than true or false? No. So it is a equally likely event. Baby is born. It is a boy or a girl. It is but obvious, right? We don't need to consider the third option. We just have to look at the two options, whether it is a baby boy or it is a baby girl. So it is a yes. Why tossing the coin considered to be a fair way of deciding the which team should get the ball at the beginning of the football game. Simple. See, if you toss the coin, whether we get the head or the tail, right? If team X and team Y, if team X demands the head, and if head comes, he wins. And if team Y, how can team Y wins? Team Y wins if tail comes, right? If X demands head and tail will be there, who wins? X wins. So in that manner, both have equal chances of winning, 50-50%. So both have 50-50% of winning chances. Both have 50-50% of winning chances. When we toss a coin, the outcome of head and tail are equally likely. So the result of an individual coin toss completely unpredictable. So that is why it is a fair way to decide the. Now question number 4. Which of the following cannot be a probability of an event? Now here we need to know the range. So it is always 0, 1 or in between 0 and 1. It is not less than 0 or not greater than 1. Okay. See 2 by 3. See 2 by 3, that means it is a 0 point something. It is a 0.2 by 3, it's 0.67. So 0.67 is in between 0 to 1. So it is yes. It can be a probability of an event. Right? Minus 0.5. Minus. It is a minus. It is a less than 0. Can less than 0 be a possible probability? No. So that means it can't be a probability of an event. 1.5% of percentage, we need to convert the percentage into the fraction. So it is a 0.015 and 0.015 is in between 0 to 1 So we can say yes, this can be a probability of an 0.7. It is also in between 0 to 1. It is also in between 0 to 1. So we can say yes, it is in between 0 to 1. So we can say it can be a probability of an event. Right, so you need to write down in this manner. 2 by 3 is in between 0 to 1, so it can be a probability of an event. It is less than 0, so it cannot be so it can't be in between 0 to 1, so it can't be a probability of an event. 1.5, right, which is 0.015, it is in between 0 to 1, so it can be a probability of an event. Now 0.7, it is in between 0 to 1, so it can be a probability of an event. It can be a probability of an event because it is in between the 0 to 1. Now question number 5. Here probability of an event is 0.05. So what is the probability of not any? So we very well know, you see in the previous lecture, that probability of an event plus probability of not an event is equals to 1. So here we know that what is the probability of an event is 0.05. So it is nothing but the 0.05 plus probability of not an event is equals to 1. If this goes on to the another side, it becomes minus. Right, so see here, probability event plus not an event is equals to 1. Now 0.05 goes on to the another side, it becomes minus. So it is 1 minus 0.05. Now 1 minus 0.05, it is 1.0. So many students know how to subtract it. Sometimes it is worse. So how to subtract it? Cut and cut. This is 10, this is 9, this is 0. So it is 10 minus 5 is 5, 9 as it is, and 0.95. So in that way you can say P of not any is equal to 0.95. So probability of not any event is 0.95. Okay. A bag contains a lemon flavored candies only. So in a bag there is only a lemon flavor candy. if you can say it is contains an orange flavor candy. So Stallman say no, it only contains a lemon flavor candy. Now Malini takes out one candy without looking into the bag. What is the probability of getting that she takes out? Now the question is, she takes out an orange flavored candy. See, now you think thought of one thing. There is only a lemon flavored candy out there in the bag. If you if your hand goes into it, right? If you pick any a candy, it is only and only a lemon flavored candy. It is a truth. It is universal truth. Why? Because we know that it has only and only a lemon flavored candy. So can it be orange? So what is the probability of getting orange candy? It is zero. Simple. It is zero because there is a no orange flavor candy. So it is impossible even to get the orange flavor candy out of this bag, right? So let an event A. How can you write down this sum? So you need to describe first of all the event. So let the event A is an orange flavor candy. So probability of an orange flavor candy is 0 because it is impossible event. Now what is the probability of getting probability that she takes out? Probability that she takes out a lemon flavored candy. So lemon flavored candy. So a bag contains only lemon, and lemon flavor candy. If you pick any a candy, it is only and only a lemon flavor candy. So it is a truth. It is a certain event. It is a certain event. If it is a certain event, then what we can say? The probability is 1. So how can you write it? Let the event be, because A is already named. So now we have to take let the event be a lemon flavored candy. Therefore, probability of an B is 1. That means, so probability of getting a lemon flavored candy is 1. Now, 7th sum. It is given that a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Then what is the probability that 2 students having the same birthday? It is simple. Probability if an event plus probability of not an event is equals to 1, right? Because it is directly given. See, just if you observe one thing, probability of 2 students is not having the same birthday. Not having the same birthday, that means let an event E bar, 2 student doesn't having the same birthday, and that is 0.992. So what is the probability that 2 students having the same birthday? Right? Let the event E be the 2 students having the same birthday. So probability of E plus not an E is equals to 1, because not an event we already know, that is denoted by bar. If it is A, then it is A bar. If it is a B, then it is a B bar. Here we can consider E, therefore it is a E bar. So E bar, 2 students not having the same birthday. E is let 2 students having the same birthday. So we have P of E plus P of E bar is equals to 1. P of E bar is equals to 0.992, that is already given. Now if 992 goes on to the another side of equals, it becomes minus. So it is 1 minus 0.992. And here P of E is equals to 0.008. So how? So it is 0.992 divided by. So this is the simplification stuff that you need to do by yourself. But once I'm going to do it for you. 10, 9, 9, 0. 10 minus 2 is nothing but the 8. 9 minus 9, 9 minus 9, and 0. So it is 0.008. So 0.008. So the probability of 2 students having the same birthday is 0.008. So that's it for today. So that's it for today. Here, I hope you see this very easy sum. Very easy sum. You can get out of means if it is a 4-mark chapter, right? It is a 4-mark chapter, right? So you get 4 out of 4 marks, right? So just prepare it very nicely because it is very easy chapter. You just need to remember 2-3 formulas and 2-3 things. Total 6 to 7 things you need to remember out of in this chapter, and you will get the directly 4 marks, right, out of 50-mark question paper. So what to say? It's bye bye. Work hard. We'll meet into the next lecture. Till then, bye bye.